SimCenter FlowEFD is a front-loading CFD tool that is fully embedded in the most popular CAD programs, such as Siemens NX, Solid Edge, CATIA V5 and Creo. In this video, we'll be looking at heat transfer and condensation simulation of a rear automotive light using SimCenter FlowEFD within NX. Let's take a look at our rear lighting. The ambient air is 20 degrees centigrade with 40% relative humidity. The air inside of the housing is defined by the fluid subdomain at 90% relative humidity. FlowEFD can automatically recognise the complex internal region, shown here in blue. Two membrane materials are set at these locations at the top and bottom of the unit. The predefined automotive vent in FlowEFD engineering base is chosen to allow air and water vapour to pass through based on pressure and moisture gradients. The purpose is to remove moisture and eliminate unsightly condensation and water ingress into the unit. 4 diffusive radiation sources with 7 watts are set at the tungsten filament of each light bulb. The radiation is calculated by using the Monte Carlo ray trace method for this model. The reflective surfaces have a special radiative surface applied with a high specularity and low absorption. Let's take a look at the results. We can use the cut plot to examine the solved parameters. For example, temperature or relative humidity. Similarly, we can utilise the CAD geometry to generate surface plots. Next, let's take a look at the ray trajectories calculated by the Monte Carlo method. Zooming in, we can see the ray bounce off at the reflective surface here and travel through the transparent material. Now, let's study the condensation with a lens with a transient study. Condensation will occur naturally as long as the lighting systems are not sealed under dry or vacuum conditions. When automotive lights become foggy, it weakens the light output, which can be dangerous, especially during wintertime. In some worst cases, the corrosion caused by humidity can also be a serious problem. Let's figure out how much of a predefined 10 micron film thickness is burnt off over a 600-second period. Building a solution on top of the steady-state result we have, we can greatly save the computational cost. Utilising the Transient Explorer, we can see the film thickness on the lens with respect to time. As expected, we see as the light bulb is generating heat, it dries the middle part of the lens, closest to the bulb. And there's more condensation at the corners. Also, we see that the lower section has more film built due to gravity. If we were to run the simulation longer, we'll be able to see the lower section clear up as well. As this example has shown, SimCenter FlowEFD not only helps the design engineers to front-load CFD analysis for heat transfer and flow analysis into the design process, but also provide accurate thermal modelling of lighting sources, including LEDs. Fully embedded in Siemens NX, SimCenter FlowEFD keeps pace with the speed of design and minimises disruption to the workflow. For additional information about FlowEFD and how it can help you, please go to the link on screen.